Hello, welcome to part 2 of the balancing equations lecture. What I've done for you is I've picked two equations that are typical of kind of tricky equations, and I'm going to go through each one, show you why it might be a little bit more difficult than a basic equation, and show you a way that you can tackle each one of these and get the right answer. We're going to start with this one here. Aluminum plus oxygen yields aluminum oxide. Let's start by looking at, I want that to be black, I think. Let's start by looking at why this equation is so tricky, and in order to do that, we're going to account for the number of atoms on each side of this equation. So there's one aluminum in the reactant side, and there's two oxygen in the reactant side. There are two aluminum on the product side, and three oxygen on the product side. And this, right here, is what makes this equation so difficult. And it happens so much that I usually refer to it as I usually call it the odd even situation. Odd even. So you'll notice that on this side of the equation there's two oxygen, which is an even number, and on this side of the equation there are three oxygen, which is an odd number. Well, here's the interesting thing. You can take an odd number and multiply it by another number and get an even number. What? For example, if I take 3, which is an odd number, and multiply it by 2, I get 6, which is an even number. So you can do that. You can change an odd number into an even number. However, you can never take an even number and multiply it by another number and get an odd number. That is impossible. And if you doubt that, you're more than welcome to try. I'm sure the math world would be stunned if you found out a way that would work. So basically what this means is if we have an equation where we have an even and odd situation, your only choice is to change the odd number into an even number. The odd number has to be changed into an even number before it will work. So let me show you what that looks like. The easiest coefficient to use to try to change an odd number into an even number is 2. Because anytime you multiply any number by 2, you get an even number. So what we're going to do is we're going to start by trying a coefficient of 2 in front of the aluminum oxide. So that changes the aluminum to 4, and it changes the oxygen to 6. And now we have an even number. And you can multiply an even number by another number and get an even number. So now we'll go over to this side and we'll look at our oxygen. We have 2 oxygen, we want 6. If we multiply by a coefficient of 3, that gives us 6 oxygen. And if we multiply our aluminum by a coefficient of 4, that gives us 4 aluminum. And then both of these atoms are the same on both sides of the reaction, and this equation is balanced. So the rule, I guess, if you wanted to call it a rule, whenever you have an odd even situation, is before you're going to be able to balance that equation, you have to change the odd number into an even number, and then you'll be able to balance the equation after that. So that's the odd even situation. Let me scroll down here a bit, and I'm going to show you the second situation that might cause kids some problems, and that is when they encounter an equation like this one that has one or more polyatomic ions in it. Now most kids would see this and they'd say, oh my gosh, this is a nightmare. There's lead, nitrogen, there's oxygen in 2 different places, there's sodium and carbon, there's just so many atoms to keep track of. But here's the beautiful thing about equations with polyatomic ions. If the polyatomic ion appears on both sides of the equation, then you get to treat it as if it were one thing when you're balancing. And so what I mean by that is instead of having to write out lead, nitrogen, oxygen, sodium, carbon, you can actually write lead and count how many leads there are, nitrate, which is NO3, because it appears on both sides, sodium, and instead of writing the C and the O separate, you can actually write carbonate because it appears on both sides. So instead of having to keep track of all of those different things, you're really only keeping track of 4 things. So let's see how this plays out when we try to balance it. There's 1 lead on the reactant side. There's 2 nitrate on the reactant side, there's 2 sodium on the reactant side, and there's 1 carbonate on the reactant side. On the product side, there's 1 lead, there's 1 carbonate, there's 1 sodium, and there's 1 nitrate. So it looks like the only 2 that aren't balanced, lead's balanced right now, and carbonate's balanced right now. It looks like the only 2 that aren't balanced are the nitrate and the sodium. So if I need 2 sodium on this side, I'm going to put a coefficient of 2 out in front of the sodium nitrate. And that's going to change the sodium to 2, and it's going to change the nitrate, because we're treating it like one thing, to 2. And then look at that. Look at how easy that was. Now the nitrate and the sodium are both balanced. So the rule is when you have a polyatomic ion, if it appears on both sides of the equation, you can balance it as if it was one thing. As always, if you have any questions about balancing these trickier types of equations, feel free to ask in class, and thanks for watching.